Okay, now we will see a quick word count in pig just to let you understand that, because at least you should be able to know, or you should be able to write in the interviews basically the big word count, high word count, map reduce word count. Okay, there are a lot of word counts they may ask you, just to test whether you know the basics or not, right? So basically what we'll do is we will create a file, put it in our input directory. We'll create input directory. Okay, and let me first create that. So I don't require Hive now, so let me exit out of it. Sorry. We should be having Hadoop fs minus ls. So do we have input? No. So basically what I will do is, again, let me create a word count. We should also have the word count. No. Okay, so let me create word count dot text. I will say, hi, how are you? I am, no, you can just write everything. Hi, how are you? I am fine, thank you. How are you? I am also fine, thank you. So this is the data that we are going to put. Create a file called Hadoop and Hadoop fs minus mkdir and put as input. And then put this file into that Hadoop fs minus put word count dot text into input. Okay, the data is there now. In pig, what we'll do is basically we'll create we can say lines, whatever. Lines is equal to load anything that is in the input directory. Okay, and we also need to associate a column to it, as we will define the schema for us. So I will say line, and char array is the data type. Oh, so let me exit out of it because we have enabled the hcat so I don't want to use it, otherwise it will try to find everything in the Hive. So in this attempt also it was trying to connect to Metastore, that we don't want because we have the data locally available on our HTFS. Okay, so lines is created. Then what we do for each line, generate flat tokenized line as well. Now we need to understand what does it mean. Okay, so tokenize it, what it will do is it will tokenize, it will try to check the data. So if I say cat on word count dot text, so it will just pick that there is a space delimiter up here. Okay, so by default there is space delimiter getting used in pig, and it will just split the words or split the line or just delimit the line using space and create those many words out of it. Okay, so what it will do is tokenized line will create an array of that, and flatten will just generate each record out of that. Like, so we will just see them separately. How does that work? So basically, instead of words, I will try to copy it. For each lines, generate flatten. So first check how the tokenize will work. Okay, so now just dump the words. So actually we got an error, we did not specify the forward slash. Again, now let me rerun it. Okay, now if you see, when we use this tokenize, right, tokenize line, So in line what we have this data. Okay, this is the data that we had in the line. So it means that we have got a bag, right? From here to here we have got a bag. Within the bag there are tuples. Okay, each one of them is a tuple. So this is one row, this is one row, this is one row, this is one row, this is one row. Okay, so within the bag we have full of tuples. So this is what actually tokenize will do. Tokenize will just check which is a splitter on, or how you can split the data as per a frequently occurring delimiter within the data. So we do a space the delimiter. So it has broken the complete line with the delimiter and generate those many words out of it. Okay, those many rows actually out of it. Okay, so if you see, this is the bag full of tuples. Okay, that is how we need to understand it. Now I will put a flatten keyword in front of it. Okay, now what flatten will do? Flatten will get these bag of tuples as the input. Okay, to it. What it will do is it will generate them as an individual tuple. Okay, currently it is one bag full of tuples, so that's currently one line only. But if you run flatten on it, it will give you separate lines for each. So it will give separate line for high, separate line for how, separate line for r, and like that. That's what is flatten will do. Okay, so let me rerun it. So we are just changing the definition of words now. So I have now, if you can describe the words and try to understand its structure, how it will look like. Describe words. So you will find that word a character array. It would be a character array. Okay, so it will generate a character array. Only one field would be there. It means that every row will be generated like hi, then second row would be how, third row would be r, fourth row would be u. Now let me just dump words and try to see how the data looks like now. So instead of a single line, we will have multiple lines. So each one of them will be in the different line we will have. Now this is how the output looks like. So every one of that line is a single tuple. Okay, so there is no bag at all. This is single tuple, this is single tuple, this is single tuple, and so on. So you got around 18 rows out of it. Now finally what we need to do is we need to group words by word. Now we need to understand the schema of words. So if I say describe words, you will again get words word character array. Now what I will do in the next step is group words by word. Okay, so I am just grouping them. Okay, so what will happen is this high will be grouped, this how will be grouped with this how, whatever. U will be there, U will be grouped. So U, comma U, comma U, you will get this. Okay, then thank, comma thank, you will get this as a group. Okay, I'm just grouping it. Now if you dump on group, you will see they will be grouped together. So you will find group of I, there are two counts in that. M appears 2 times, I appears 1 time, R appears 2 times, U appears 4 times, right? Now what we need to do is we need to do the counts for these two guys. For these two guys, so for this one guy, for these two guys, 2, 2, 2. So we need output as like I comma 2, M comma 2, I comma 1, R comma 2, how comma 2, U comma 4, also comma 1, find comma 2, thank comma 2. Okay, so we have this 9 individual words with, we need to now do the word count on that. So basically what will happen is when we dump grouped, we need to understand it is schema. Describe is grouped. So if you see, for each grouped means for each of this row. Okay, now we need to generate group. What is the group? This is the group, that is this one, the first element, and the count of words. So if you see, there are two basically columns in it, or you can say fields in it. One is group, that is of char array, and there is words, that is of this thing. So basically we just need to count the words. So it's just like kind of select star from select stars, or select a field and column, field and the select column and comma and the count of that column. Okay, or count 1 or count star, whatever. So it will just give you the count as per how many times that word appears, right? So I will say counter or counter. So for each grouped, generate group, that is this one group, comma, these words, the count of these words, right? Count needs to be capital, maybe it is how it is written. This is a keyword. And now just dump the counter. And this is how the final result look like, I2, M2, R2. So this is your word count, right? This has been done again in how many lines in pig? Only 1, 2, 3, 4, 5. 5 lines in pig, 5 lines, 4 or 5 lines in hive, but 150 lines in original Java. Okay, so that is a problem. So even pig is also equally, you can say efficient in order to provide this kind of analysis. Okay, just like hive does, right? But in pig, basically you can just do the transfer. You can see the transformation in each sequence by sequence. You can just dump it and try to see if you are going in right direction. That's what actually is very easy. Pig is very easy in terms of doing the transformation one step after the other step. Okay, you can again perform some kind of joins also, just like in hive we do perform join. We also can perform the join in pig. Okay, so basically I just let you through the join. I mean, it can be easily done. Again, you just need to have two data set, and that is the. So basically, let's say there are two different data sets, and one common key should be there, so that on which you can perform the join. So basically, let's say load as exchange symbol date open hive locus. So this is, let's say this is one schema. This is second schema. You see that exchange and symbol are like both on date dividends. We can have so basically it is join daily by symbol and divide divs. So this relation is joined and this relation will be joined by symbol. Okay, this is how you just need to write. Rest is just like select join between in hive tables, right? So you do have two tables with one common field. So here we do have three different common fields. You can choose any one of them to be the join key on which you want to join these two relations, and you will have the join relation of daily and divs and just like that. So you can just create your own data set and try to do that. It's again very easy. Okay, and then with some little practice, more practice, basically you will again be very, and pig is quite easy to work with.